In this video, we are going to practice solving and graphing inequalities. So just to begin, a reminder that when we are graphing, certain signs mean that we need to have a closed circle on the number, and certain signs means we have to have an open circle on the number line. So our signs that constitute an open circle are greater than, less than, and not equal to. They have an open circle on the number line because it means that that number is not included in the possible solutions. If we have greater than or equal to, less than or equal to, or equal to, we will have a closed circle on the number line because the number that we are discussing is a possible solution. In this example, we will practice solving an equation or an inequality. So, to start, we know we want x by itself. So instead of adding 5, we are going to use the inverse operation, which would be subtracting 5. Whatever we do to one side, we also do to the other. Now, even though there's not an equal sign, it's a greater than or equal to sign. We think of it as the same as an equal sign. We just work out the problem normally and just keep that sign at the end. So, on the left, we are left with x. And on the right, 10 minus 5 leaves us with 5. And we keep our same sign. Now, when we are graphing this, we'll put a little tick mark for our 5. Okay. Now, we have a greater than or equal to sign in between our x and our 5. So this means that 5 is a possible solution. Therefore, we will have a closed circle. Now, we know that x, our possible solutions, are going to be greater than or equal to 5. So numbers to the right of 5, like 6, 7, 8, 9, are greater than. To the left, we know they're less than. 4, 3, 2, 1. Because our x is greater than or equal to 5, we are going to shade to the right because these numbers are all greater than 5. Okay, our next example, we have x minus 3 is less than or equal to 12. So again, we're going to use the inverse operation. The opposite of subtracting 3 would be to add 3. Whatever we do to one side, we do to the other. We are now left with x on the left. We keep our sign less than or equal to, and 12 plus 3, which is 15 on the right. We'll graph this as well. Put our tick mark for 15. Okay, again, we have less than or equal to, meaning that 15 is included as one of our possible solutions. So we will have a closed circle on 15. Okay, in this case, our x, our possible solutions, are going to be less than 15. Numbers less than 15 will be located to the left of 15 on the number line. So we'll go ahead and shade in the left. Okay, our next example, 4x is greater than 20. We know that 4 and x are being multiplied because they are right next to each other. So the opposite of multiplying by 4 would be to divide by 4. We do the same thing to both sides. On the left, we're left with x. We have our greater than symbol. And 20 divided by 4 leaves us with 5. Now we'll graph this solution as well. We'll have 5 on our number line. Okay, we know that the numbers to the right are greater, 6, 7, 8, 9, and to the left are smaller, 4, 3, 2, 1, and so on. Okay, in this case, we have x is greater than 5. So our possible solutions are going to be greater than 5. 5 is not included as one of the possible solutions, so we have an open circle on our number 5. X is greater than 5, so we'll shade in to the right because these numbers are greater than 5. Okay, our last example of solving inequalities is x divided by 2 is less than 7. We want x by itself. The opposite of dividing by 2 would be to multiply by 2. Whatever we do to one side, we do to the other as well. This leaves us with x on the left is less than 7 times 2, which is 14. And we will graph. which is 14. Again, our possible solutions, or x, are going to be less than 14. 14 is not included, so we will have an open circle. Numbers that are less than 14 will be located to the left of 14 on the number line, so we will shade in the left. You can also remember that our sign should look like the end arrow that we shaded in, if that helps you remember. Okay, I just wanted to reiterate the fact that when you flip the numbers, that doesn't make an equivalent inequality. So, x being less than 8 is not the same as 8 is less than x. For example, if we plug in 2 for x, 2 is less than 8, but 8 is not less than 2. So this is just a reminder that if you have the number before the variable, if you want to switch the order, like putting our x first, you must flip the sign. Let's plug it in again to check. So if x equals 2, we'll say x equals, in this case, we'll say x equals 10. Okay? So if 8 is less than 10, 10 is greater than 8. So just remember, if you flip the order, you have to flip the sign. Okay, and a couple more examples. If we were to graph x being equal to a number or x being not equal to a number. So, in the first case, x equals 3. Okay, the only possible solution for x would be 3. So we would have a closed circle on 3. Now in the second case, x does not equal 4. Okay, we know that 4 is not a possible solution. So we are going to have an open circle on 4. Any other number could be a solution except for 4. So we would shade in both to the right and to the left. Okay, we will do one example of writing an inequality from a number line. So if I asked you to write an inequality from this number line, we would start with x. Oops, I didn't shade in. Okay, we'll start with x. Now, you always write the number that the circle is placed on. So -2. We're dealing with -2. We just need to decide what kind of sign should go in between. So, we know that the numbers to the right of -2, are going to be greater. -1, 0, 1, 2, 3, and so on. Okay, and those are the ones that are shaded. So x is going to be greater than -2. Second thing we need to decide is if we need that line, that equal to line, underneath our greater than symbol. Because we have a closed circle, we know that -2 is included. So in this case, we would need the line. X is greater than or equal to -2. If we had an open circle in the middle, we would just have that greater than symbol. But because it's filled in, we know it's greater than or equal to.